also want to say hello to you all. And this is the Coffee Lecture Data Documentation, a prerequisite for reusable research data. I'm Nadine, and today we will talk about tips and tricks that will help you in your data documentation routines. And why are we doing data documentation? It serves a number of purposes. It minimizes the probability of misunderstanding in collaboration and data reuse. It reduces the risk of data loss. Knowing what you have and where it is actually really helpful protecting it. And it improves day-to-day working practices because it enables step-by-step improvement. If you want to know more about this, I ask you to go back and watch the recording of the coffee lecture of my colleague Kevin Lang from last week, because that's really nice introduction to that topic. And keeping the need to document things in mind from the start allows you to choose your tools wisely and adds an important aspect to that decision. So once you've made yourself aware that you want really to document your data, the next point is that data documentation takes time and effort and it involves trade-offs. So more is always better, but more costs more. And you have to find something in the golden middle that suits you, suits your practices, but is also helpful to others. And to do that, there are a few things you can just take as guiding posts, let's say, and that is choose software that makes documentation easy. Everything that logs what you're doing, everything that helps you with templates or other things that give you guidance on how to document with this software is a real plus. And then choose standards that are available to all and everybody. Through this type of practice, you can retrace your steps in the research and you can see who contributed what, which is absolutely necessary to know once you're writing up your article afterwards and you're trying to give credit where credit is due, using things like the contributor role taxonomy, which needs to be kept in mind from the start to be filled out properly. So you've got all these things in mind, and then you go and try to choose your tools, use your ELNs, and do the things you need to do. And if you're documenting, you're helping yourself understand your own process in the days, months, and years to come. It coordinates the way your team members contribute their aspects of the research, put their things into writing. And it's an important step towards collaboration in the team, because everybody uses not only the same words, but you can make sure that they mean the same things by using terminologies, by documenting which units of measurements are used in what fashion and how you put them down. So that's really important and makes checking, commenting, and improving each other's works easier by removing the need to ask for clarification before commenting. Publishers also want you to document what you're doing because they increasingly require materials in addition to the papers. You can no longer just write up your research, put the results in and say, that's it. We've had the replication crisis, and that has taught us all that research can only serve as a basis for scientific progress if it adheres to rigorous standards. And these standards can be boiled down to the question, do I have everything I need to follow in your footsteps? Are you giving me clear enough directions and materials that I can rerun your analysis, arrive at the same numbers, and follow the reasoning that led to your conclusions? And more publishers want this type of material. They are not happy with just the article. They want the data, they want the scripts. So you need to do documentation for the publisher as well. And those incentives align with the incentives the scientific community gives you, because science can progress faster if data and methods are shared widely and enable a multiverse approach to replication. That means not only rerun the same script, but take the data, rerun them with another method, take other data, use the same scripts, things like that. And that's only possible if you've got properly documented methods and data from the start. So this is really great and helps science if you've documented the things. Funders, in turn, also want documentation because they need proof that their money has been put to good use. And especially for exploratory research and anything that has a serious probability of being interesting in the start, but then going to a dead end, it's helpful to be able to show that what you did was actually sensible and that the result is valid, although it is a dead alley. So a clearly documented fail helps others. They are not going to go down that way again. And documentation is nice, but a bit to do. When you think about documentation, normally you start from scratch, but you could just turn that around and start from the finishing line. You choose your addressee and think about who needs to understand me. And if you think about the people we just outlined, you see the people who most need to understand you are those who would publish a paper because they are in the middle. And if you clear that bar, everything else is fine, probably. And okay, maybe your funder needs a bit more. Maybe they need a SUP or a DMP in addition to your research data. But if you clear the publishing bar, that's a nice idea. So we're going to have a look at how can I document in a way that it is okay for a publication. And the other things, how to document in a DMP, that's the coffee lecture of weeks previously. There is the slides I linked here, and those are the considerations you would go through. We're not going to deal with it in detail here. And the standard operating procedures, neither. It's just a placeholder here. There has been a coffee lecture last time. But where you can go and look for guidance for documentation is you can look at the data requirements of journals. There, you as an author are the target group, and you can try and find out what you need to do to fulfill those. You can look at the data primers of the data curation network. The normal targeting group would be data curators, but as you can compare what the different formats entail, that's a really good shot at choosing a format that needs not so much extra work when handing it into a repository. Or you can use resources and tools that are more detailed, that cover small specific aspects of data documentation. I've linked a few in the pink section down there, but the main point is they are there and it's helpful to use them. It's helpful to search for them. And the things you can look at are there specific DMP tools for my subject? Is there a tools manual for my most used research software that shows me how I can use it to document what I'm doing while I'm doing research? Because sometimes it's really in there and it's really, really helpful. And you can use resources like the data curation profiles, which are a kind of history of a specific data object, and they provide you a structure where you can describe what has happened to a specific data file. And the turn of its life. And then you've got tools like StatTag and StatRep, which help you form the link between your statistics and your paper, or give you an overview of the overall projects you've got. But all this is rather piecemeal and a bit all over the place. And so I thought maybe it's helpful to start really at the end and see what the social science data editors ask of you to hand in. If you hand in an article that needs to be accepted, and they actually have quite distinct guidelines and provide you with a README template that is giving you all the necessary information they would need to accept a paper. And that's great because it shows you what do you need to document from the start if you want to be able to hand in your paper afterwards with minimal questions and minimal necessity to redo things. So I've linked you all those resources, and we're going through the content of this README template to give you an idea of what you would need to do. First of all, you would need to fill in a data availability statement, which is information on where to find the data you used and how to access the data. And there you are not going to just hand in everything and say that's okay, but you are going to differentiate things you took from external sources, where you took them from, under what conditions, from the things you generated yourself, and you're going to outline what other people can do with those data and how they would need to proceed to be able to access it. What does this imply for your own documentation? It implies that you need provenance information for every bit of data you're going to include in your replication package, and you need to keep track of the data generation processes. So you need somewhere to write this down, and you need to set that up from the start to continually add to it. And this information is helpful to other people because it gives them an idea how much time and effort and probably money do I have to invest to get to the data I would need to replicate that article. And this is really valuable information. And for you yourself, it is also valuable to put it down in writing because it gives you an idea how much this project was difficult or costly data-wise, and what to ask for from a funder next time you try something similar. And then the next thing is you fill out a statement about the rights. I just copied the language from the template. The point is that you see there that use and redistribution are different rights, and you have to keep track of both of them. You must make it visible that you've got the right to use everything you use, and why you've got the right to redistribute some things and others not. And your documentation needs to be sufficient to allow others to verify the things you've said. To do this, you should use a reference manager, preferably one that allows you to import data through a one-click. And if you want to verify if your own reference manager is up to date, I would advise you to just try and import something from Zenodo because they've got CC statements which are embedded there. And if your reference manager fails at importing those, you should just check for an update for your reference manager or check for a better reference manager because you want to be able to import licenses alongside with the data automatically, and you want to be able to keep track of them. And keeping track of the licenses others grant or do not grant for the data you use is necessary to be able to give licenses for the outputs yourself, because that depends, or that gives you the dependencies you have to, well, realize. Then you should, in the next step, say where the data is available. And you've got several options. The important point is that you do not have to hand in all the data. It is really good if the data is publicly available somewhere. You just have to make sure that if you use public data sources, other people can verify that your public data is indeed the data they are seeing when they're following your link. So include the checksums and really make sure that the data citation is something that works and that leads to the right type of data. If you use confidential data, you see here that the data editors expect you to store it for a number of years. This would be negotiated when handing in papers, but knowing that is good because then you know, okay, I can have something in my home university. I can store it there and just safekeep it without handing it over to others. The practical advice is that you should follow the instructions and list the data files contained in your replication package. You should provide certain descriptions. For example, you should describe the format. That's handy because we've got that list. You should provide a data dictionary. There you can either hand in a separate file with the data dictionary, or you can describe the data in the files you hand in Starter, for example. That's possible. In other data formats, it's not. You should list the availability within the package, and you should use proper bibliographic references. I'm going to show you the tables in where they demonstrate how they propose you do this. And it's really helpful to have seen this type of documentation before. There's some additional information where you can just look up which format description is good, how you could create those data dictionaries. So it's a bit more than I'm just talking about here. The summary in tabular form is structured as follows. And you see there's a data name, a data file location provided, and citation. So this part at the end is what your reference manager puts the file under. And to keep it consistent, a reference manager is a good tool to use for all the documentation. Then you've got the dataset list, and you see that the data file name is the same as the file name in the table before. And you say a bit more about where it came from, if it's confidential or not, if it's provided or not. And all these things can be kept with your raw data in the folder of your project from when you start your project to be able to fill out those tables afterwards. Then you are expected to talk about computational requirements. If you need libraries, code packages, extra software, computing hardware, everything that's not just common. And the point is, if you have got a setup, it kind of fades into the background and you do not really remember what things are in your normal environment that other peoples do not have. If you try to list those from the start, you know your dependencies better and you can better replicate what you've done before. So that's a reminder to do so in this template. And it's also suggested to distribute the dependencies alongside the other data because you can't be sure that things you created before, you downloaded before, will be still available in 10 years' time, for example, when other people read your article and try to replicate your results. So you should try to distribute what you desperately need with the replication package. And if you're not allowed, at least link to it. And if you create things on your own, it's a strong recommendation that you please publish your own code as well. You also should give an indication of how much memory people would need, how much runtime it would take, how big the storage requirements are. Because if you have got uh, an amount of data that cannot be computed on a normal desktop machine, that should be clear from the start so that replications and attempts do not fail unnecessarily. And then they've got hints on how to describe your program, your code. They do not want detailed descriptions. They just want a high-level overview. And they want you to name the program and file, short description of the purpose. They don't want redundant files. So anything that was there and was used before but is not used in the final article should be removed. And they want you to license the code you include if you can do so, because it's your own. The instructions for the replicator should be clear and succinct. They want a human readable instruction, but only a simple list, no prose, a strict linear sequence. And if there are more steps than say 4 to 5, they expect you to put all this into code. So that's a strong incentive to do as much as possible in code from the start. And that also helps you as a group to make things redoable, to reuse the parts of your analysis for other projects and to make it person independent, because you can hand along the code, but you can't just take your head off and give it to another person. They want to document all this in the list of tables and programs, where you should identify which program created what output, i.e., what table, what figure, and where they appear in the manuscript. And this list should be provided in the following fashion. And it should also include, we're going to come to the table, and it should also include the reasons why a repository might be incomplete and a clear statement on why the data could not be shared. So this is how a list of tables would look like. And it seems really simple, but this type of template is quite a lot of help when you're keeping it from the start and filling it out on the go. And then you can later just extinguish all the lines you do not need because some figure disappeared from your article and you don't want it anymore. That's easier than just having to redo it from scratch. So there is a hint for publishing code on the Nodo. It's quite easy because there is a GitHub integration. And if you want to create nicer metadata, you should just use the citation FF files to enhance your metadata. If this was a bit too from finish to start, I also included a data integrity checklist, which gives you everything we mentioned here in the typical order. But I thought it was nice trying to do it backwards because that's a good idea why you want to do all the stuff. Okay, I listed the sources for the template, and that's all from me for now. Before I finish, I want to remind you that the Thüringer FDM Tage will take place from 18th to 19th June, and we kindly invite you all to join us when we're talking about tools and Thüringer Praxisbeispiele. And yeah, that's so much for me. Thank you for your attention.